Good afternoon, guys. So we're going to be looking at chapter 8.5, homework help. These are the problems that I'm going to be helping you out with today, number 24, 44, 76, and then 92. What we're going to do with these is just be able to solve them to help you see how the lecture from yesterday helps with the homework. So I'm going to start off with number 24. 24 says that you're taking the absolute value of 5x minus 3 that is equal to 22. And now remember, with the absolute value, just like we talked in class, we have two different outcomes. One that will represent the positive. I'll put a little plus sign right there so that you can see, and one that represents the negative component to it, right? So what we do is just basically do the algebraic component. Now that we've separated them, I get to use the addition property of equality, where I get to add 3 to both sides. Remember, that simplifies because of the additive inverse, and then we end up with 5x is equal to 25. Get to use a division property of equality, where I get to divide both sides by 5, and I end up with x is equal to 5. So that's my first set. And now remember, this is an inequality. This is not an inequality. This is an equal one. So that means that you're going to get only 2 solutions, as opposed to an inequality will represent an infinite number of solutions. So remember the difference between the two. So I'm going to do the same thing with the negative component. So I'm going to have 5x minus 3 that is equal to negative 22. I use the addition property of equality. I get to add 3 to both sides. That simplifies for me, and then I end up with 5x is equal to negative 19. I get to use the division property of equality, where I get to divide both sides by 5. So x turns out to be negative 19 over 5. So these are the two answers that I have for problem number 24. Alright, so here's number 44. I chose 44 for a unique reason, because towards the end, when we actually find the solution to this, you're going to see that we are actually going to end up with only one, and that's because of the manipulation that I'm about to do. If you remember the last problem that we did, number 44, it had a positive solution. As you can see here, I'll put it in blue. It had a positive and it had a negative. This one should also have a positive and negative, but because of the manipulation that I'm about to do, something unique happens. So let me go ahead and get started. In order for something to work, it has to look like this, and I think we talked about that in class. And then we get to separate it into x is equal to k, and then x is equal to negative k, right? And it works that way because of what the absolute value does. For this particular example, I notice that there is a 3 here, a negative 3, and I'm multiplying the absolute value by a negative 10. So there are 2 things that I need to get rid of even before I think about setting the absolute value into a positive and negative. So what I'm about to do is I'm going to take this negative 3 and I'm going to add it to both sides. This simplifies, and then I'm left with negative 10 times the absolute value of of 16x plus 4, that is equal to 0. And now I get to do the division property of equality to be able to divide by negative 10. This simplifies to 1. 0 divided by negative 10, I still end up with a 0. And now I have the absolute value of 16x plus 4 is equal to 0. At this point, I would be able to break it into 2 different ones, and I'll show them to you so that you can see. So we'll have the positive, so we'll have 16x plus 4 is equal to 0. That will represent the positive one that I was talking about. And then the other one will be a negative, so it will be 16x plus 4 is equal to negative 0. But in math, we don't have a negative 0. So what ends up happening is that I only have to be able to solve for one of these, and it works out perfectly fine for us. So let me go ahead now and solve for the variable x here, where I get to do the subtraction property of equality to be able to move the 4 to the other side. Now I have 16x is equal to negative 4. I get to do the division property of equality, and I get to divide by 16 to both sides, and I see that x is equal to negative 4 over 16. Then I get to simplify, because we always want things that are done in the simplest form. So I get to divide both top and bottom by 4, so I end up with negative 1 forth as my final solution for this given one. And it just so happens, again, that for this particular example, because on the right hand side, we ended up with a 0, we only have to do it once. But if this was a number, instead of the 0, if the 0 was a number, then we would have to also introduce that negative component here and be able to solve for it. Okay, so this is number 76. These are the good ones that we were talking towards the end of class about. Remember, the rule says if you have the absolute value of x such that it is, let's say for example, less than k, we get to see this in two different ways. We have to represent when it's less than the number and when it's greater. Or remember how we talked about that it will represent the negative numbers and the positive numbers. So we will say that we end up with x is greater than k, and then the second one will be x is strictly less than negative k. So this time we get to introduce this less than, as opposed to before it was just either equal to a positive number and a negative number. Now remember, the rule still says though it has to only be the absolute value to it. As if you look at our example right now, we have the absolute value and then we have this -5 that's attached to it. So we actually have to move it to the other side before I start breaking it apart. So I'm going to do that right now. I'm going to do the addition property of equality that allows me to move the 5 to the other side. And now I'm left with the absolute value of 2x minus 5 is strictly greater than 25. And at this point, I could go ahead and break it up into the two inequalities that I have. Okay? So the first one's going to turn out to be, let me do that in a different color. So the first one's going to turn out to be 2x minus 5, strictly greater than 25. And the other one, and this time it's or, right? Or is going to be 2x minus 5, which is strictly less than -25. And I'm just going to go ahead and solve them now individually and then look at them in interval notation as well. Okay, so I'm going to use the addition property of equality to be able to move to the other side, and I end up with 2x is strictly greater than, right? I end up with 30. Then I get to use the division property of equality, and I have x is strictly greater than 15. How does that look like on a number line? Remember, all we need is three numbers: 0, positive 15, negative 15, and at this particular point at 15 it's going to be an open circle and it's going to be everything to the right of that. Or think about it as an interval. It's open parentheses all the way up to positive infinity. So the way that we address that will be from 15 parentheses all the way up to positive infinity close parentheses. Now let's look at the second one. I get to do the addition property of equality. This simplifies and I end up with 2x is strictly less than -20. I get to use the division property of equality where I get to divide both sides by 2. I have that x is strictly less than -10. We look at this in the number line again just to see how it looks. Positive 10, 0, -10. Because it's strictly less than, it's an open circle and it's everything to the left of that. Right? And then how do we do it in interval notation? It's parentheses here all the way up to -infinity. So -infinity, comma, to -10, close. Now, because we are talking about the or statement here, it could be somewhere in here where the answer is, or somewhere in here. We have to put the union of these two interval notations. So we have -infinity all the way up to -10, union with positive 15 all the way up to positive infinity. And this will be the answer that we're looking for, to be able to describe that we do have an infinite amount of solutions, and as long as it's in between -infinity and 10, not using those two numbers though, and the union of 15 and positive infinity, if the answer that we're looking for, that x that we're looking for, it's somewhere in there, then it will be part of the solution at the same time. So this is the last one that we're going to be looking at, which will be number 92. I chose this one because of the first step. You notice that the absolute value has a multiplication of a -1 in the front. So I have to get rid of that first before I start breaking it apart. So I'm going to divide both sides by -1. But the rule says, if you divide by a -1, what happens to the sign? The inequality itself is actually going to change. It's going to flip. And then a -8 divided by a -1 gives you a +8. Now at this point, I can go ahead and break these two up into 3x plus 1 is strictly greater than 8, or I get 3x plus 1 is strictly less than -8. And from there we do the basic math to be able to figure out. Then we do the number line, we put them together to get the solution. So I get to use the subtraction property of equality. Then I have a 3x is strictly greater than, I apologize, that should be a 1. So I get to subtract here and I end up with 7. I get to do the division property of equality where I get to divide by 3 and I end up with x is strictly greater than 7/3. How does that look like in a number line? I'll put -1 here, I put 0, and I put 7/3 here, and it's strictly greater than, so it's an open circle, and it's everything to the right. Okay, the interval notation for it is going to be parentheses 7/3, comma, all the way up to +infinity. Let's look at the next one. So we have subtraction of 1 to both sides because of the subtraction property of equality. Simplifies and I end up with 3x strictly less than -9. I get to use the division property of equality and I end up with x is strictly less than, right? Strictly less than -3. The number line for this right here is going to be +3, 0, -3, open circle, and is everything less than that. Okay, the interval will be from -infinity, comma, to -3. Close it with a parentheses. The union of the two is going to be from -infinity, comma, -3, union with, open parentheses, 7/3, comma, to +infinity. And that will be the final solution to what we have. Remember, keep on doing your homework. I encourage you, show up a little early to class and ask me any questions that you may have, okay? Thank you.